Last episode we built a RAG pipeline and we breezed past one step with a wave of the hand. Store the vectors, then search them. That little phrase hides one of the harder engineering problems in modern AI. Here is why. When you only have 1,000 chunks, searching is trivial. You can compare against everyone and never notice. But real systems do not have 1,000 vectors. They have 10 million, 100 million, sometimes billions. And users expect an answer in the blink of an eye. So the question becomes, how do you find the closest needle in a haystack of 100 million in a few milliseconds every single time? That question is what gave birth to an entire category of tool, the vector database. Quick note before we dig in. If you find this useful, subscribe and drop a topic you want explained in the comments. Now let us get into it. Here is the whole idea in one sentence. A vector database is a specialized database built to store huge numbers of embedding vectors and find the ones most similar to a query vector almost instantly using approximate search instead of checking every single record. To see why that word approximate is doing so much work, let us first look at the obvious approach and watch it fall apart. The simplest possible search is called brute force, and it is exactly what it sounds like. You take your query vector and you compute the cosine similarity from episode 3 against every vector you have stored, one by one, then sort them all and take the best. And it is perfectly accurate. It is also hopeless at scale because the work grows in a straight line with your data. Every query has to touch every vector. At 1,000 items, instant. At 100 million, every single search grinds through all 100 million and your snappy assistant becomes a spinning wheel. Brute force does not scale, full stop. The fix is a beautiful trade and it is called approximate nearest neighbor search, usually shortened to ANN. The deal is this. You give up a tiny sliver of perfect accuracy in exchange for an enormous leap in speed. Instead of dutifully checking every vector, you build a clever index ahead of time, a structure that lets you leap straight to the right neighborhood and skip the overwhelming majority of your data entirely. The most popular of these is called HNSW, which stands for Hierarchical Navigable Small World. Do not let the name intimidate you. The picture is simple. Imagine a map of your vectors with layers of shortcuts laid over it, like express lanes on a highway. You start zoomed all the way out, take a few big hops to get near the right region, then drop down a level and refine, and again, until you have homed in on the closest matches, having examined only a tiny fraction of everything you stored. That word approximate means just occasionally it misses the true closest match and grabs the second closest. In exchange, you go from grinding through 100 million to glancing at a few thousand. For retrieval, that trade is almost always worth it, and you can tune the dial between speed and accuracy. Now, fast search is the core, but a real vector database gives you more than a raw index, and this is the difference between a library and a full database. First, metadata filtering. In practice, you rarely want to search everything. You want the closest chunks from this user's documents, or only from this state range, or only of this type. A real database lets you attach that metadata and filter on it while it searches. Second, the everyday database basics, adding, updating, and deleting vectors as your documents change, without rebuilding from scratch, plus saving it all to disk and scaling across many machines. And third, hybrid search, combining the meaning-based vector search with old-fashioned keyword search, so you catch both the semantic matches and the cases where an exact word, a product code, a name, really has to appear. Together, those turn a search trick into infrastructure you can run a business on. So let us name the real tools, because the brief demands it and the landscape genuinely matters. First, an important distinction. FAISS from Meta is not a full database, it is a library, a blazing fast in-memory engine for approximate search that you embed inside your own code, with no filtering or storage of its own. Then come the actual databases. Chroma is lightweight and runs right on your machine, the easy default when you are prototyping. pgvector is an extension that bolts vector search onto PostgreSQL, the classic database, so your vectors can live right next to your normal application data instead of in a separate system. Pinecone is a fully managed cloud service. You never run a server, you just send vectors and queries. And Weaviate, Milvus, and Qdrant are powerful open-source vector databases built for production scale, which you can run yourself or pay to have hosted. The mental split to keep is simple. FAISS is a library you build with. The rest are databases you store in. So how does this land depending on who you are? As an individual, you never touch a vector database directly, but it is the quiet engine that makes search my notes by meaning or find that photo by description feel instant. As a startup, the smartest move is to match the tool to your stage. Start with pgvector or Chroma. Do not bolt on heavy infrastructure you do not need yet, and graduate to a dedicated database like Pinecone, Qdrant, or Weaviate only when your scale actually demands it. And as a large enterprise, the vector database becomes serious, governed infrastructure, holding billions of vectors with access controls and reliability guarantees, serving as the shared search backbone underneath every internal RAG system in the company. So let us bring it home. Brute force similarity search is accurate but collapses at scale because every query has to check every vector. Vector databases solve it with approximate nearest neighbor search, indexes like HNSW that trade a sliver of accuracy for an enormous gain in speed, and they wrap that in real database powers, filtering updates, scale, and hybrid search. FAISS, the library, Pinecone, Weaviate, Milvus, Qdrant, Chroma, and pgvector are the databases. Now, here is the catch that pulls us into the next episode. The fastest search in the world is worthless if you are searching over badly cut chunks, or if a close but wrong passage keeps landing at the top of your results. Speed does not equal quality. The two levers that actually decide whether you retrieve the right thing are how you split your documents in the first place, and how you reorder what comes back. That is chunking and re-ranking, and it is where we go next. That is the core of it. If this helped, hit like and subscribe, ring the bell for the next deep dive, and tell me in the comments what you want broken down next. Thanks for watching.